Today we have Daniel Tillier. The root of his rapid prototyping manufacturing business go back to 2010. The business started off with modern style furniture and has evolved to what is now today developing end-to-end products for traditional customers and startup businesses. Daniel has been crafting with various mediums, wood and electronics, since he was a small child, but didn't start diving deeper into his passion until he graduated college and rented his first apartment at his first military duty location in 2010. Vandenberg Air Force Base in California. He wanted to fill his apartment with unique and modern furniture, but that came with a high price. He realized he could build similar furniture for a fraction of the price. After doing so, friends requested similar furniture pieces for their homes. After receiving a very touching and personal going-away gift from his unit at Malmstrom Air Force Base, he was touched with inspiration to create unique and personal gifts for others using his lathe to create rockets for people that had helped launch during their time at Kirtland Air Force Base. The gifts continued to evolve and get more complex, requiring more and more time to complete. That is where he turned to automation. Over time, he bought 3D printers and a CNC machine. This automation allowed him to have a profitable business on the side, reducing the time spent on projects and allowing for increased accuracy and complexity. Thank you. He taught himself how to build and operate these machines, design and program. At the end of 2016, he had gained enough tools, machines, and skills to commit his business full-time. Through automated machinery, Daniel had the flexibility to continue bringing customers customized gifts and help additional customers design and produce products for their business or personal use. He was able to work on a number of projects at once, essentially doing the work of many on his own. Since then, Tillier Designs has worked or partnered with numerous small businesses, military units, and individuals to develop physical and digital products such as custom plaques, merchandise for sale, fixtures for his business, design, art, and precision products for aerospace. Daniel's here today to show us how 3D printing, CNCs, and other automation technology can help provide greater precision, increased detail, simultaneous workflow, and lower the overhead costs of designs during production. Thank you, Daniel.
So, good morning, everybody. Thank you, Nick, for that introduction, and thank you, Shane, for kind of setting this up.
Oh, you bet.
Thank you, everyone, for having me here. So my name is Daniel Tillier. I started a company called Tillier Designs, as he said, back in about 2010-ish. And next slide. So today we're going to go over about Tillier Designs as a company, kind of how it started, what we do. And then we're going to talk about CNC in general. And then specifically we're going to talk about the X-Carve CNC, which is a type of CNC that I use. And then we're going to go over things such as CAD CAM software, and then maybe go over a brief case study of how I've used it in my workflows, and then also how to contact a CNC shop if you don't have a CNC and you would like something CNC'd. And then chat it up with some questions and comments, and then if anybody has any questions during the middle of the presentation, feel free to ask as well. Oh, it's frozen. Okay, there we go. So, about Tillier Designs, it's a rapid prototyping, industrial design, and manufacturing business. In other words, I make stuff. I had to come up with a fancy term for that one. But I pretty much run a garage micro factory where I use desktop technology, which we'll kind of get into a little bit later what desktop technology is, and self-education and online communities to learn about how to continue to adopt new technologies and advance my business. So, next slide. So some of the services that we offer, this doesn't actually include all of them, but is CNC engraving and carving, 3D printing with FDM and SLA. I was told that there was going to be a 3D printing workshop later on in the future, so I didn't include much about 3D printing in this presentation. I do a lot of woodworking and computer-aided design, also known as CAD, and some metalworking.
Question.
So,
You might tell me the difference between the two types of 3D printing.
So SLA is a stereolithography apparatus. It's kind of a tongue twister, but and so that one, it uses pretty much a a tub of resin, UV cured resin, and it sits in this tank, and it has a clear screen at the bottom, and a laser shoots across and hardens that resin while the build plate will pull that object out of the pool of resin there, and it'll continue to build it that way. And it's really high detail, high quality prints that way. And then FDM is fused deposition modeling. And so I like to say it's like a hot glue gun, but with plastic instead, and it's automated, so it pretty much makes layers by layers to create a new object from the bottom up. So pretty much it's like a hot glue gun, as in it has a hot end and it shoots plastic instead of the glue through to kind of do that. So that's kind of an automated process in that one. So, all right, next slide. So, how I started, you heard a little bit about it. I moved to my first apartment at Vandenberg Air Force Base, and I really wanted some fancy stuff. And unfortunately, that cost a few $1,000s, and as a brand new lieutenant, I didn't have that money. So I was like, well, you know, I like building stuff, so you know, I might as well just kind of make it on my own. And so I started doing that. As he said, my friends would come over and be like, "Oh, you know, can I get that too?" And it's like, "Yeah, sure." And so I charged them a little money to do that. And then eventually I started making stuff for the missile wings and everything like that, and like pieces of furniture here and there. And it was kind of fun to be creative. And thankfully, I had a landlady that was nice enough to let me to work on the porch there, and kind of build my own thing. So this is actually the first table I built right there. And then
you build a car?
Yeah.
Wow.
That's actually
I'm impressed.
that's actually a goal of mine, to build a car one day. But this is actually a picture of me outside the apartment with a bunch of wood and stuff like that sticking out of my car. That's all I had at the time, and I actually still do that today. So next I went to Malmstrom Air Force Base, where at a military unit, and there's some job locations as well, it's kind of customary to give a going away gift, kind of to remember the unit, all the things that you did there, and then and just kind of show appreciation. And so my airmen that were working with me, they did this amazing thing where you can see the little Hot Wheels car there for the red car, and they took like this sheet of steel and some plumbing accessories and parts and electrical parts. I think it's electrical box for his chest. And they built me a robot. So they called me Lieutenant Tink Tink because I have a titanium leg. And the stand-up comedian made a skit about a guy named Tink Tink, so they called me Lieutenant Tink Tink at the time. So that's why they built me a little robot. And they signed it there, drew pictures and everything, and it was really touching. And so I was, you know, I was being so touched to it, I keep it around today and everything. And so when I went to my next base, the going away gifts, which was at Kirtland Air Force Base, the going away gifts there were kind of cold and mundane. They just put up like 4 pictures in this kind of like a montage thing of space stuff, and you know, people would sign it. They'd just be like, "Good luck," or "Bye," or something like that. You know, it was really just like meh. And so I was like, well, we could do something better. And then so I started making off these little base plates out of plywood, and I'd make every one different and kind of special to that person. If you actually looked at this from a vertical angle, it's the delta for space wings and stuff like that. So I tried to make something a little bit more special, and something that obviously took a little bit more time than just saying, "Oh, good luck," or something. And then the company is like Orbital; they would provide the rockets. When I saw that, I was like, well, you know, that's not how they actually looked. So when the company provides these rockets, they're like these. It's a general shape, but they're not all white. They're not shiny. And the stickers or the decals on the rocket aren't that big, and there's a lot more of them. And so I was like, oh, you know, maybe I can make them a little bit more realistic. And so that's when I started. I bought a lathe, and I started actually carving them out of wood. And so I would sit there and spin them up, and then I'd try to paint them kind of like they really look. So this one here is a Minuteman III missile, and this is a Minotaur I. This rocket right here is made from parts of this rocket. So it's not all white. It would more have tan and green and all kinds of stuff in there. So that's how I started going with that. Over time, I started getting really tasked because people were leaving like crazy, and I couldn't keep up, and I had to work during the day. Actually, I had to do my job, and then so I would come home and spend all night doing these things, and so I learned about 3D printing and CNC and automated stuff, and that was able to open up a whole world of complexity and open up my free time as well. So that's kind of where I'm at today, is where I've acquired enough machinery, automated technology, and experience to partner up with numerous companies and units, military units, and individuals to come up with unique and physical and digital products. So on average, I have about 10 projects in a parallel workflow. Right now, I think I have 14 projects that I'm actually working on right now, and some are actually being made while I'm here. So it's kind of nice. And so these are some of the things that actually I've done in the past few months, and as kind of examples. And this is actually a box of hops that will be going into space, and they had me make the acrylic box for that capsule to go into space. So
Hops?
hops, beer hops.
Oh,
Yeah, yeah. So it was a part of a Kickstarter campaign. Sir.
That middle one, is that made out of glass? That one right above it.
Oh, this one right here?
Yeah.
That is actually out of cast acrylic. So when working with the CNC machine, there's kind of two major types of acrylic. There's extruded acrylic and cast acrylic. I'm not sure. I mean, obviously it kind of goes into the name on how they're made, but I'm not sure exactly the process. But CNCs work best with cast acrylic. So if you ever do if you do have a CNC machine and you do go to, like, say, Port Plastic to get some acrylic, ask for cast acrylic, because the extruded acrylic will ball up into one big giant molten ball of acrylic and mess up everything. So,
okay.
Sir,
The plexiglass you buy at Lowe's, is it extruded or is it?
it is extruded. Yeah, and so I actually ran into that problem the first few times I tried to work with acrylic, as I bought it from Lowe's or Home Depot, and I was like, man, this is turning out pretty bad. and I found out why.
The castable stuff goes under, I believe, thermoset, and that's a chemical reaction. A hardener and your basic resin.
That makes sense. So that kind of helps it kind of resist that kind of temperatures and stuff go through.
There's a lot of companies that make that stuff for hobby use and such. It's used quite a bit in the film industry.
That makes sense. Thank you.
Appreciate that.
And where can you buy the cans?
So Port Plastic is the place I like to go to. It's
PORT?
Yes, sir. Yes, sir. Kind of like a port of ship.
And they're located where?
I think it's
Candelaria.
Candelaria.
Mm-hmm.
Yep, that's the one. That's the one. Mm-hmm. So it's off of there, and so it's they offer a variety of different types of plastics there as well. Both cast extruded acrylics and variety of different colors and types. It's a pretty nice place, and it's a lot cheaper than going to Lowe's or Home Depot, too. So CNC. What is CNC? It really stands for computer numerical control. Pretty much, it's having a machine or tool that is controlled by a computer and is in an automated process. So you can pretty much have any different type of CNC when it comes to, like, lathe or water jet cutting or plasma cutting, saws, mills, and the list kind of goes on and on. Robotic arms, for instance, and those are all different types of CNC. And technically, 3D printing kind of falls under CNC as well, but they have this own little major subgroup of additive manufacturing is more usually what it's referred to as 3D printing, but you can kind of go into CNC as well. It's the same premise. And just like any other tool that you have, a CNC is whatever type of CNC you have, it is made for a specific purpose. So, so I really can't use a CNC lathe to cut a plaque. So it's going to work just like a lathe does, but it's just automated that way. So we're going to talk about first industrial versus desktop. So industrial CNCs are commonly used to perform routine tasks in a manufacturing workspace. They're typically large in size, typically expensive. When you look on the website, it says call for a quote or contact us for a quote, and that's usually not a good sign. And then they're usually high precision and high speed, which is wonderful as far as like getting things done quickly and the quality that you end up getting. One of the downsides is training is often required. I guess that could be an upside or downside depending on how you look at it. And then also maintenance technicians are typically needed to repair the machine if something goes wrong or if you have a part that needs to be replaced. Also, one of the plus sides to an industrial machine is it works with a large range of materials. So, you know, you have some industrial CNC machines that can work with titaniums and steels and a bunch of different hard metals and materials. And one thing that you're going to notice is that they're proprietary. A lot of the things that go into these industrial machines are still covered by patents. And a lot of the technology that goes into these specific machines are proprietary, as in like the interface that you have to work with the machine, the screen that goes with the machine, and also in some cases the pathways that the bit will take inside the machine to cut the whatever object you're trying to make are also proprietary as well. So next, and actually what I'm going to do right now is last night I saw a video, so I wasn't able to put it in the slides, but I saw a video that actually shows a really good example of a industrial machine. So some of the things I highlighted there obviously was the tool changing. You usually don't see that in a desktop machine. You usually see that in industrial level machines, automatic tool changing, as well as the clearance that the machine had. You could see that it had a huge workspace and everything, including vertical workspace as well. And some of the other things were kind of probably the speed it was going at. It was a time-lapse video, but it also probably would have still, taken a little bit longer if it was a desktop machine.
There was a time that they have a 4x8 CNC machine at
Fuse Lab.
what's it called?
Fuse Lab.
Yeah, Fusion. And we contemplated having the machine, cut out our parts for our toys, for our little toys. But I think we shut that down when we realized running one piece of plywood through there could take, I don't remember, but it was too much time, hours to cut one thing. We could do it faster on a jigsaw.
Exactly.
So that's just the nature of the beast.
It is the nature of the beast. It also depends on what kind of level machine you have. There are some machines that will rip through that in a second or two. Yeah. But those are really, really expensive machines. And I'm not sure what type of, I have seen the machine there at Fuse Mecha Lab, but I'm not sure which one they have. But But yeah, it's kind of the nature of the beast. And if you are going to get a desktop CNC, you probably will have to spend a lot of time, just waiting for that part to get cut out. You'll get nice parts, but it'll take a while. And that's one of the things that we'll talk about in the case study is that you kind of need to balance whether you should use like a jig or something like that versus a CNC machine, because you still have that time that is associated with that. But they do. There are certain levels of machines that will just rip through that, and it's kind of cool if you look it up. I'm not sure it's a European name for a company, but it's like Orsod or something like that, and they make a bunch of like nice bits and $10,000 bits for machines, and you can see them just kind of just going through material just like nothing, and it's really cool to see. So if you ever look it up on YouTube. Sir.
This old house has done a couple of things that they've done with CNC machines and building stuff to go in. Mm-hmm. And you can probably go on their website and see some of their videos where they've used them. I'm not sure which episodes they are.
Mm-hmm.
This old house.
This old house, right. They've done that where they've come up with special designs. They did tongue and groove stuff that go in for rafters they were making. There's
Nice.
supports that go in there with it, and some other curved beams.
Mm-hmm.
They did on a CNC, but it was a commercial job. I mean, these are huge machines.
Oh yeah.
I wouldn't even probably even fit in this room.
Yeah, some of them can get huge, but they can do really cool stuff.
I wanted to say that the Valley High School wood shop has a 4x8 CNC shop bot machine, and what they don't have is a computer to run it. So they got a $15,000, $20,000 machine sitting on the wood shop floor and never use it. They're trying to get expertise and the stuff they need to make it work. I've been going in volunteering to try to help. I don't know anything about it. I'm very interested in your talk, but it's useless.
So, desktop CNCs are, they perform the same tasks as their industrial counterparts, but they're usually smaller and lighter machines. So the term desktop comes from being able to place that machine on your desk. Now granted, the CNC that I have is still considered a desktop machine, but I can't place it on my desk. But but it is 4 foot by 4 foot, so I can at least place it on a good workbench. And so it often doesn't require specialized training. And it's DIY troubleshooting and modifications and repair. So pretty much when you get one of these machines, it's kind of up to you to learn more about the machine, to kind of get educated. And the nice thing that is there's tons of online communities that are devoted to helping you out. And a lot of these people have already posted the question that you might have. And so you can already follow the thread. If it's 3 a.m. and you're having a problem with your CNC machine, then you don't necessarily need to call customer service. You just go onto the website, search your problem, and somebody might have is more than likely already dealt with that problem. And that's the wonderful thing about these online communities is they'll help guide you through. If you can ask questions if you can't find the question there that's already been answered, and you can look through previous issues and kind of build off of that. And so that's actually one of the reasons why one of the 3D printers I bought, I bought it as a kit printer. So because of the community coming from it and behind it is because you can make modifications and do all kinds of stuff when you have that community. And now they can usually, like we were talking about speed, they could be a little bit slower and a little bit less precise. We'll get into accuracy a little bit later on in the presentation, but modifications can be made to mitigate those to an extent. And then,
if I may say, in my perception, price has always been a barrier to entry. Because I'd like you to give us some idea of the span of dollars, because I'm sure it's coming down with competition. But you can get a lot of cool floor machines for what it costs to get a CNC, and then you got to learn how to run it.
Yeah, that's right. And we'll get into price, I think, on the next slide. It has a kind of a comparison of price, but Now it's becoming a lot easier to learn these things with those communities and videos that are out there, as well as and the price is coming down to a really good spot for so normal people can have it in their shop and not break the bank. You know. And is there a question back there? Both. So. So the question was, does it come with a specialized router or spindle that will go into the machine, or can you put your own in there? And the answer is both. So usually when you do go through the ordering process online, it will come with a spindle, and you can usually select what kind of spindle you want or router that you want to put in there. And I've also seen people modify it to water-cooled spindles and everything like that. And so then you could take it to all new levels. There's this one guy who has an X-Carve as well, and which is my machine, but he cuts metal, but he does it rapidly. And but he has all kinds of water cooling machines and stuff going onto the spindle, and it's actually pretty cool looking to see. But yeah, so you can modify it to whatever you want, really.
Tell me what kind of router you put in.
Oh, so I before I bought one of the first versions of the X-Carve, and I modified it to put a DeWalt 611 router in there, which is a wonderful router. And actually, so many people started doing that they actually started supplying the machines with a DeWalt 611 router in there. So, because everybody was just modifying it to that anyway. So this is the X-Carve. I think this is about the same size as mine. Actually, it might be the version smaller. It comes in different versions, big, up to 4 foot by 4 foot. To small, which is actually able to fit on a desk and put in. They use that one a lot for classrooms and education and stuff like that. Or if you just don't have the need for a big old router or a CNC machine, then you can get that one as well. It's a 3-axis CNC milling / routing machine. It can work on a bunch of different materials depending on the bit that you have. And what you have available as far as modifications. For instance, mine can work on wood, acrylic, metals, soft metals, that is, leather, foam, carbon fiber. I've cut carbon fiber before, and the price range is going to be around $1,300 for one of these machines. Granted, you can put enough modifications or buy enough extras to really bump up that price, but you're looking at around $1,300, even less for the smaller machine.
But that includes the router?
Yes, sir. Yes, sir. And so
is that a kit version or is that assembled?
It's a kit. And so, the thing about it being a kit is you're going to learn by building it yourself. I really would recommend buying a kit 3D printer or CNC machine if you are going to go that way. Everybody has their own opinions on that, but I would recommend that because you know what happens when it goes wrong. If it starts acting wonky, you know that one of these parts are loose or a wheel fell off or something like that. Because you're going to have to deal with that one day, and you're just going to be like, what is going on? But then you might actually have to go into the control board and rewire it and everything. And what they do is they supply you with every single part to build this printer. I mean, not printer, but router. But you have to, even the connectors you have to put together yourself. On there, sir.
What's the capacity of that?
Capacity.
How big of a piece can you work with?
So 29 by 29 in the X and Y direction. X is side to side, Y is front to back, and then 2 inches in the Z direction. So 2 inches, yes, sir. So unfortunately, it doesn't have a lot of clearance. Unlike that last CNC that we showed a video of, that had a ton of clearance. I'd like to have that one day. So I might do a modification to do that. All right, so next slide, please.
What's the height? 2?
2 inches. 2 inches, and that's workable space. So the actual machine itself is 4 by 4 by, I'm not sure how tall it actually is, but that was workable space. It's 29 by 29 by 2 inches.
So that might be one of those. This might be one of them.
Yes, sir.
That's it. Okay.
Yes, sir. And it looks exactly the same, whether it's the small version or the big version, just larger.
Is that a vacuum hold down? Just looking at the surface one day.
Oh, this.
The holes, all those holes.
Oh, the holes. Oh, okay. So those are actually so you can hold your material down. So what these right here, these little clamps right here, those will bolt into those holes. So those are, so you have to insert the threaded inserts into those holes. That comes pre-drilled if you buy this option of a waste board. This is called a waste board right here because it kind of can go to waste. You can see the cuts in there. And so these clamps right here will go down, and you put your material there. Let's say a rectangular material that goes right here. Then I put the clamp right here and here, and then hold it down, and so that way it stays nice and secure on the workpiece.
I think I see some of the catalogs where they make a big deal of vacuum holding them down. Why wouldn't this work? Or is that easier to work?
So vacuum is, well, one is going to be more expensive and harder to implement. Two, let's say you don't actually have a flat piece on the bottom. You might have a little issue pulling a vacuum on that. I haven't had too much experience with the vacuum hold downs, but I'm assuming that that's kind of going to be the case on that. So this is kind of like an affordable method of doing the same thing. But then again, you can't work on like your entire piece because you might hit that the little clamp or something like that. So you would need excess material to work on if you wanted to cut out a piece. So.
Hey everyone, it's Zach from Inventables, and today I'm here to give you a tour of the new X-Carve. One of the coolest parts about X-Carve is the vibrant community that's been built up around it. That's really meant two things. First, an unbelievable amount of sharing and camaraderie as people are working on their machines and making stuff. And the second is a lot of feedback. Everybody in the community has been really active in giving Inventables feedback about what they want out of the machine and how they want it to improve in the future. X-Carve is a great machine to get you started on your 3D carving journey. We're seeing a lot of you start with learning how to do an engraving and then turning that into signs. Some of you are even making a business out of selling signs. Within schools, we're starting to see widespread adoption. Teachers are turning the traditional bake sale into a make sale, and students are carving out signs and plaques and selling them at parent-teacher nights. We're seeing a lot of you push forward beyond signs and making things like furniture, guitars, and some people have even made quadcopters. It's all really exciting. Everyone at Inventables is on this maker journey with you.
So adding a CNC router to my tools really increased diversity, complexity, and quality out of the things that I made. It allows me to work with multiple materials in new ways. I'm not just stuck to one specific material. I can work on acrylic 1 minute and switch over to aluminum the next, and do wood as well, and all in the same day. And I don't really have to switch much out. I can carve in 3 dimensions, X, Y, Z, as we kind of talked about earlier. And the community has really allowed for those modifications and tech support. It's been really helpful. I can't stress that enough. And some of the modifications I've done is I've upgraded the stiffness of my machine to reduce vibration. I've also added vibration dampening, and I've also added laser attachment so I can do laser engraving. And so here's some of the things that I built. My wife and I, every once in a while, we do art night where I decided to carve out the world map there, and then we painted all the stuff on the inside. And question?
What wood the table is made of?
So the waste boards actually, I believe, is made of MDF. So the waste board's made of that. The rest of it is, I believe, it's steel frame, and aluminum and steel frames. So aluminum rails that go from side to side, and steel frames holding up the side. And then this is actually the first thing I built with the CNC. It was kind of interesting. I didn't know what I was doing at first, so when I started the machine, it just went straight into the wood. And I was like, oh my gosh, I don't know what's going on. So I had to learn the code pretty quickly on that one. And then this is something that I made for the SpaceX team that actually lands the rockets it's a shadow box to hold the flag that was on the ship when the rockets landed. And it's actually in the shape of the ship, the drone ship that catches the rockets. So with the engravings that are on the actual ship right there. So some of the limitations. 3-axis is actually a benefit and a limitation at the same time, because you can start to go up to 5, 6 axes. And the more axes you have, the more ability to cut different ornate things into an object and get it from different angles. So because it's a 3-axis machine, if I have my workpiece, flat on the table right here, I can go up and down, I can work on that, and I can go side to side and front to back. Now you can do anything, but you can only do it on that one side of the workpiece. So if I wanted to work on the other side, I would have to remove that piece, flip it over, and then re-zero out which is pretty much zeroing it out is kind of lining up where your material is and where your bit is. And so you and your design and the computer are all on the same page. You have to re-zero it out and everything and make sure that everything's lined up if you want to work on both sides. And since I have a 2-inch height limitation, I can't work on the side of a project. Let's say if it's like a plaque or something, it'll be larger than 2 inches, so I can't engrave on the side. But if I do have something that is, smaller than 2 inches, then I can work on the side of it. Question?
Suppose you wanted to work on both sides with the same design, and when you flip the material over, what's the overall accuracy of the machine to align the top side with the bottom side, so to speak? Yeah.
So that's really going to come down to the user on how well they zero out the machine. And as far as accuracy goes, the machine, my machine at least, can get down to 0.0029 inches in accuracy. So it's going to be fairly accurate as far as the eye can see. And then the better you align that piece up and take the steps to align it up right, the better results you're going to get. And I have done that before, where I've had to flip a piece over and work on both sides. I spent a lot of time measuring, but I got it, and it worked out just fine. And then we talked about this kind of the size, the work area limitations a little bit earlier, 29 by 29 by 2 inches. And then material limitations, I can't work hard metals. I can't do like steel or anything like that in my machine. My machine won't take it. But I can still do soft metals like aluminum, copper, brass, etc. So as far as accuracy goes, as I said earlier, is kind of highly dependent on the user, as well as how well the machine was built. Keep in mind, if you do get a kit machine, or let's say even the machine was delivered to you or pre-built, then it all depends on how well it was built. If that level or the bed is not level, then you're going to have some issues as far as height issues go on the material. And then let's say some of the rails are off, then you're going to have some XY issues. And if things are loose, as far as maintenance goes, if things are loose, you can have vibration issues, which can show up in the quality of your work. Also, the bit quality. Are you working with dull bits? That can cause some major issues as far as how well you can cut, as well as the finish of your cut. And
where do you go to sharpen?
So that actually I don't know. I just go ahead and buy new bits. That personally, but I am sure there's a way to sharpen them. But I haven't dived down that arena. And you can most bits you can find on Amazon.
I was just going to ask you how expensive.
Yeah. I actually don't have to replace them too often. If you use the right feed rates and the right RPMs on your router, then getting those right will reduce the wear on the bits. And that comes through A, trial and error, or B, through calculations on doing that properly. Oh, sir.
You should be able to go over to precision sharpening.
Oh, okay.
Which is where we take a lot of saw blades and stuff over there for them to sharpen.
So they could probably do it over there? Okay, that's perfect.
You use high-speed steel or solid carbide?
Both, actually. So I think I'd use carbide more than high-speed steel.
With the feed and speed, do you have any trouble with burning edges of wood?
I actually, I did in the beginning. I did have issues burning the wood, but I haven't seen that pop up recently. So I think I'm either getting better at it or. But I only saw that in the very beginning, seeing burning on the edges of the wood. And so it also depends on how well those bits were made. If you, because like, you can buy them on Amazon, you can buy them on eBay, but I've had some that I've bought on Amazon or eBay that have like broken in the first 5 seconds of, and so, but I've also had some that were also very cheap, like, you know, 10, 20 bucks on Amazon or eBay that have lasted to this day, actually, since I bought them. So it's been a good at least year that I've been using them. So it also depends on your material that you're working with is going to be a huge thing. Let's say, and especially material versus bits. If you're using the improper bit on a material, then you could, you know, you're not going to have the desirable results. You might be able to cut the piece out. I've had to, in the pinch, you know, use a bit that really wasn't supposed to work with a certain material. Granted, that bit went away really quick, but yeah, so that's going to probably decrease your accuracy a little bit too. Also, the modifications that you may have done on that printer, on that CNC machine, will also greatly improve your accuracy as well. And then it also depends on, like I said earlier, the user, on how well they line up stuff, the pathways that they pick. The pathways, when I say pathways, is pretty much the path that the bit takes along the material, and how well you zeroed out that material. And then, so as I said earlier, the typical accuracy is going to be around 0.0029 inches to around 0.0051 inches. Granted, you can get better and you can get worse, so keep that in mind. So as far as requirements go, in workspace, you just need a large enough area to put it. In my case, I need a 4 foot by 4 foot area. I don't need any special outlets. 120 volt outlet works great for me, and that's all I really need. Sturdiness, the vibration. If you have a lot of vibration in your material or in your machine, that can also cause quality problems. So if your table's just shaking and everything like that, you got to remember this thing is being pushed around at a very high speed, and you have a router. Just so imagine a router going at 100, let's say 100 inches per minute going across, then and back and forth like this, then you're going to have a lot of vibration. So you want to mitigate that as much as possible. So the place that you put your machine, you don't want it to roll around or shake or anything like that. And then noise. You got to remember this is a router, and then it's vibrating a lot. It's doing a lot of different things, and it's cutting into materials. You're going to have a lot of noise with it. So you might not want to operate it at 4 a.m. next to your bedroom while your wife's sleeping. But just kind of keep that in mind. They do actually make some CNCs that are enclosed and will fit on a desk, so you could have it in your apartment. I think it's called a Shapeco. Was one of those, and so it has a lot less noise, but still kind of be respectful of your neighbors in that case. And then electrical noise too. There's a lot of electronics that go into these things, and so you want to mitigate electrical noise as much as possible. So that's crosstalk from wire to wire. So you don't want a bunch of cables just hanging off of it and everything, that without the proper devices to mitigate that. And then because when you have that electrical noise, it can mess with the code. It can cause shuttering. It can cause the whole thing to just shut down mid-print or mid-carve. And then your computer connection. You just need to be able to connect to a computer that's able to operate those programs. And then optional is dust collection. Now, it's highly recommended because that puts off a lot of dust. a lot of dust, a lot of little bits and parts that go everywhere. So I would definitely get a dust collection, or at least have a vacuum next to you to kind of take care of that.
What is the computer connection? A USB or?
Yep.
It is?
Yep. It's USB for my particular CNC. I have some devices in my workshop that are Bluetooth. I have some that are actually connect over Wi-Fi. So yeah. So as long as your computer's capable of that, it's just a simple connection, really.
So what do you do for dust collection?
Dust collection. So I did have a dust collection set up with a shop vac, and I had one shop vac and it burnt out, of course, because it's not meant for prolonged dust collection. And then I made my own dust collection unit, and then I got a Harbor Freight one. But then I reorganized my entire garage, so right now I don't have any dust collection hooked up, and I just vacuum every once in a while, and then wear a mask, when I'm working with really, really bad materials like carbon fiber. Yeah, you definitely need to. You don't want to breathe that in at all. Sir?
You have some kind of shroud around the router for the dust collection?
Yes. So in most dust collections for the CNC machines, there's a little shroud that goes around. You see them in different types and different ways. Usually it's like an acrylic piece or a 3D printed piece or something like that goes on, that attaches to the router, and then it has like a kind of a net around it. Sometimes it's like little broom fingers, and it's some type of way to create suction around there. And so those just go over the material. Sir?
What software are you using for the router and also for the design, CAM and CAD?
So we'll go over software at the very end of the presentation, but what I use personally is, so you need 3 types of softwares, kind of a sender to send the information to the machine, a design, and then also CAM to do the CAM is for pathways. And I personally use Vertec VCarve, I think it's Vertec is the company, VCarve Pro for my CAM software. It's expensive, but it's worth it, in my opinion. We'll go over some free stuff out there too, just in case you don't want to spend that kind of money on it. Also use Universal G-code sender to send the information over to the CNC machine, and I actually use 6 different design tools. So depending on the type of project I have, so just because of the different projects I do. So
you're going to cover, because that's an integral to the cost of the whole deal. Mm-hmm. You're going to cover the combined cost of software and machine.
Didn't you get your Vectrex software with the machine?
I'm sorry?
Didn't you get your Vectrex software with the machine?
I did not. So that option is available. You can, when you're doing your configuration online, you can buy that a subscription to, or buy, it's not a subscription service, but you can buy a license to that program. So it is in the checkout process, so you can go ahead and buy it right then and there when you buy your machine.
There's a lot of people give that away with the machine.
Mm-hmm. Yeah, and I'm not sure on the promotions or deals that they have. Granted, it's been 4 years since I bought this machine, so I'm not sure what the current promotions are, but I'm sure there are plenty of different manufacturers that will provide that as well. The thing about Xcarve, and we'll really dive deeper into it later, is it comes with a program already called Easel, and it's a hybrid software that has a sender, CAM, and CAD all in one. So they're not, I don't think, really incentivized to offer Vertec or anything like that with theirs when they have their own software that kind of goes with it. So that's, I'm assuming that's why it's not included for free. So bits. So you can use in-mill or traditional router bits with the CNC machine. And there are tons and tons of different types, like I said, ranging up to, $10,000 for a bit. But the type of bit that you use for your project is really dependent on the material being cut and the type of cut that you're going to be performing. So I'm not going to use an in-mill bit, a flat in-mill bit that's 1/4 inch, let's say. I'm not going to use that to engrave because it's not going to be fine enough to get those letters engraved into the work material. And depending on the result you want to achieve, you're going to probably end up using a combination of bits. Let's say you're doing a 3D object, all right? So there's going to be something called a roughing path. Usually you kind of get a bigger bit to kind of take away the majority of the material around the object that you're going to be carving out later. And then you get a round over bit. that will go in 3-dimensionally over an object. Let's say I'm doing like a little mound right here. Then the bit will go over like this, and carve it away. And then, but that roughing path, usually with the end mill, will just go around the object like this, and then kind of get all that excess material away for that rounding bit to come in and get those fine details. Or you can, and as you saw in the video earlier, you can use an engraving bit, depending on the type of material that or an outcome you're trying to achieve. And then, so choosing the right bit is going to be a balance of the main goal, getting your piece cut, and then having the cleanest finish possible, how quickly you can do the cut, but also keep in mind the wear on the bit and the cost of the bit. Like I said, some bits out there can produce amazing results and do amazing things, but they also cost a ton of money. And if you're only, let's say if you're going to be charging for your work and your work piece is only $20, then you don't want to just go out and buy a $100 bit, just to do that one thing, So CAD and CAM software. CAD refers to computer-aided design. It's pretty much where you use a computer to design your thing. It involves anything from 2-dimensional drawings to 3-dimensional molding of objects. And you can also perform things such as structural analysis and different types of analyses on those 3D softwares if you do go to that route with some programs. And then CAM is computer-aided manufacturing. Is pretty much having a software that will tell the machine what to do and controls the software. So, okay, these are both, we went over what CAD and CAM is. So next slide, please. All right, so to operate a CNC, traditionally you need at a minimum a 2-dimensional design of your project that is readable by your CAM software. A 3-dimensional design is also fine, but as long as your CAM software can read that. There are some CAM softwares that will not be able to read pathways on there or be able to generate pathways to cut that piece if it's 3-dimensional or it's the wrong file type. It all depends on the type of program you have. Now, CAM software is used to plan the cuts and pathways, and it compiles the pathway into data that can be read by the CNC. And then you have interface software, which sends that code to the CNC machine, and that CNC then reads that code and performs the operations that the code tells it to. And I can't stress this enough. You do not need to go out there and buy expensive software until you need it. And you have to know you need it, kind of thing. So we're going to go into it in the next couple of slides, but there's free software available that can be used. And once you've used that to the max and you know what you're doing requires more than that free software can provide you, then go buy something. But until then, you're probably going to be able to get away with a lot of free software out there. Sir?
I'd like to remind everybody, the club has an agreement with SketchUp, and you get an $800 SketchUp program for $39 a year for your use as a club member. And I think Ben has all the information on that. But it will prepare drawings and save them to where you can bring them into the CAM software.
Exactly. Yeah, that's perfect. That's perfect. So,
How do you use SketchUp?
I only use SketchUp when the customer uses SketchUp. So if my customer has already designed SketchUp or designed something in SketchUp and they send it to me, then I'll use SketchUp. But I personally use other softwares, which I'll talk about in a little bit. So this is an example of a hybrid software, which is Easel. Easel is an online tool that is provided by Xcarve so you can operate their machine. And so it is a hybrid of CAD, CAM, and code sending software. So if you need to make adjustments to your machine and you need to send a certain code in there, it has a place where you can do that and just type it right in and it'll send it to the machine so the machine remembers that code. or it'll automatically do it for your certain pathways that are being cut. And so you can see here, we have that square. I drew that square just kind of for the presentation. So I drew the square in easel and everything, and then you can see here it's able to figure out what it's going to look like in 3 dimensions. And you can set the depth right here, or you can type in, it has a scale, or you can type it in right there. It's pretty easy to use, and a lot of people use it. You can also import different sketches and everything like that into the software as well. And you can generate those toolpaths as well.
Purchase that, or does it come with the machine?
It comes free with the machine, and you'll never have to pay for it. They have a pro version. I'm not sure what comes in the pro version. I haven't used easel since since the first year or so that I bought my CNC machine, because my needs went far past what easel could do. But I'm not sure. They came out with a pro version recently, and I forgot what it provides you, but the free version is just fine. So, any other questions?
Kind of basic geometric shapes.
Mm-hmm. Basic geometric shapes, unless you import your own design, and then.
What file formats do you import?
SVG Sketch is the primary one. I'm not sure. It might be able to take a PNG file or a JPEG and then a bitmap. Pardon? DXF. It'll do DXF. I think. Not sure what the other ones are. Is the DWG file? Yeah, and it'll take those. Mm-hmm. Yeah, it'll take those AutoCAD files as well. So it works pretty well as a tool that's free to use. And now it'll only work for the X cards though. If you have like a ShopBot or a Shapeco or maybe a Shapeco, it might work for Shapeco as well. But if you have some of the other CNC machines out there, you cannot use easel with it. They won't talk to each other. So some free examples for CAD are some sketching tools, or SVG Edit, Inkscape, Affinity Designer. I think that's an iMac program, and Open Office Draw. So it's pretty much so you can just draw your shapes and everything that you need to if you do not have like software like easel or something where you can draw it in your CAM software. And most CAM softwares you do have the ability to draw in, but if you want to draw it out on your own, like let's say, or you can scan your own picture into these things. So if like let's say I wanted to outline this cup, and so I take a cup, put it on a piece of paper, draw an outline of it, put it on the scanner, and then I have that shape of the cup. Let's say if it was weirdly shaped or something like that. So that's a lot of things that I like to do is if I'm taking the object that I need to copy over, I like to just, put it on a piece of paper and draw the outline of it at least to start designing. And put all the, like, let's say, I made 1911 grips once for a customer. And so I took some old 1911 grips, put them on a piece of paper, drew everything out, just outlined everything, where the bolt holes were and everything like that. Took the dimensions of it, scanned it into a regular scanner on the computer, imported it into one of these programs, just one of these photo programs, and then I turned it into a sketch in that program. And then that way I had the bolt holes were exactly where they needed to be, and everything was fit perfectly.
Tell them what a 1911 is.
1911 is a pistol, I'm sorry. So it's a type of pistol. So it's the grips on the side of the pistol that I was remaking. So.
New military type.
So some 3D software. Google SketchUp is an excellent one. And since y'all have that ability to get a discount on it, I probably would suggest using or thinking of using it or getting good with it. Tinkercad is another one. I think they do have a free version of Google SketchUp still. So, but I think it's more professional with the one you were talking about.
Oh, the difference is the files you can save. You can save the $39 club version. You can save directly to a STL file, which you can bring into either a 3D printer or a CNC machine.
Yeah, that's perfect. Yeah.
So, and then also another one which I use a lot and recommend is Fusion 360. is free for hobbyists, students, and small businesses. And so what you'll do is you can go into Fusion 360. It'll do a number of different things for you. It'll even provide CAM software as well. And you go in there, you register with Autodesk, download the program, and it'll look like you're going to have to pay. You only have a 30-day trial. I think it's a 30-day trial. But then once that trial is up, it'll ask you, are you a small business student or a hobbyist? And then once you click what you are, then it just gives it to you for free. So
You have to have an internet connection to use that.
you do have to at least get started with it. You do. It'll work in offline mode if you are not with an internet connection at the time. But it does upload and download things to a cloud server unless you specifically tell it to save to your computer. So if you're going to be working on something, let's say, and it's already uploaded to a cloud server, if you don't have the internet, you can't connect to that design. Now, if you've already loaded that design on your computer and then you leave the internet, then you can work on it still, but it won't save until you get back to the internet. So there are ways to specifically save it to your computer. It's a bit of a process, though. You'll have to go through a bunch of menu options to do it, but you can save it directly to your computer. Yes.
Just a reminder, the club has offered training on SketchUp to club members in the past. There's a big learning curve to all this stuff. And I'm sure the club will intend to offer it again. So if you're possibly interested in that, either see Ben Blackwell or myself.
And I completely agree with the learning curve thing. And what I would recommend, even if you don't plan on doing this, but you're still interested in it, just at least download one of the softwares and start to practice, kind of thing. So that way you kind of get a handle on what's going on. And the more you just mess around with it, it's digital, so you're not going to really break anything. So you just go around and draw whatever, and then find different ways to do stuff, and then you just get better and better at it. It's just all about practice, really. And then as far as free CAM software, Fusion 360 has a tab in there where you can do tooling paths as well for your 3D objects. And then also I've heard there's FreeMill, but I don't know too much about it. Unfortunately, there aren't too many CAM softwares available that are free, that at least I know of. You'll probably end up having to pay unless you use something like Fusion 360 or have something that's provided with your machine. And then you'll need CodeSender software. I still use Universal G-Code Sender. Pretty much it talks to anything that takes G-code and over USB or any other COM port. And it'll just send the code to your machine and it'll tell it what to do.
You have to buy that also.
It's free.
That's free.
Yeah.
It's an open source program, actually, and so you get it off of GitHub and everything. So it's so you just type in if you want to download it, just type in Universal G-Code Center on Google, and you'll be able to find it, kind of thing. So, yep. So all these are free softwares.
Are they all for Windows, or is there a Mac version of all of them?
So I am not sure how well Universal G-Code Sender works. I don't have any Mac computers, and I've never worked with them either. So I'm not 100% sure, but I'm sure Fusion 360 would work on there, Google SketchUp. And I think one of those is actually an iMac program. I think maybe it's Affinity Designer or Inkscape. One of those two is specifically for Mac computers. Now, but all these work on Windows computers. So, but as far as Mac computers, I'm not sure which ones are compatible, but I'm sure it'll be easy to kind of figure out. Sir?
Typically, Macs are not used with the CNC machines because it's an interrupt problem. When you're running that code, that machine is only running that code. You can't have it doing something else. And the Macs are not very good at running interrupts. And so you've got two choices. Either run a special version of Linux, which is a dedicated version, or running it on a Windows machine, which can handle the interrupts.
Next slide, please.
So, okay, we're going to kind of push through a case study of a few days of my work. And so we're just going to walk through some of my recent projects, and it's going to really highlight when and where CNC and automation makes sense in the workshop, and you can try to apply the same things to your own lives and what you do. So next slide, please. So first week in November, I received 3 orders. I got an order for custom wood coasters, 50 walnut and 50 ash. It was for a California startup company, and I had already worked with them previously on their design. I had done 3D prints for them. I had made silicone molds for them so they could make it out of concrete. And so I was, and I've already practiced before with doing it out of wood. So I already had the pathways and everything set up. So and saved to my computer. I had a Peacekeeper ICBM model ordered offline. I sell a bunch of my rocket models online, and so online customer came in, bought it, and I've made this that rocket a ton of times, and so I already had the design and it was all ready to go. And then custom acrylic pendant lights for a brewery here, Cantero Brewery. It's a pretty good place. I'm gonna stop by. They
research that.
Yeah, I researched it personally. They had me make some pendant lights for them. Evidently, their lights were burning out. They didn't tell me that their lights were burning out. They just told me that they needed them, and it's just whenever. But you'll see later on, they called me midway and said, "Oh, our lights are dying," and hurried this project up a little bit. Anyway, so they wanted 3 acrylic custom lights, and I had to come up with a design for that one. So okay, so some of the things that I have to balance out is time versus quality versus complexity. When does automation make sense as far as how complex is the task or project? Automation can allow for more complex builds, such as things like 3D printing can get details that are pretty hard to achieve by hand or by other means of tools, or impossible in some cases. CNC also can afford you that same kind of quality. And it also can reduce physical stress. Yeah, some of these things I could carve up by hand, but after carving 100 ash coasters, or 100 wood coasters, then my hands are going to be pretty tired. So, and also, how accurate does the project need to be? So with CNC machines, you have, as long as you set up things properly and everything goes well, then you can have accuracy that's replicatable. Now, let's say if I'm doing it by hand tools or some other ways, you may have the same amount of accuracy, but you also might make a mistake, kind of thing. So, and for me, that's a higher chance of making mistakes. And what other tools could be used? Sometimes it is easier just to whip out the hand router or cut it with a saw or something like that. So, and when you think of that, is like, which will give you better results? Is like, do I save any time by doing that? Or do I save effort? Or do I save, or can I multitask? So one thing is like, sometimes it would be quicker just for me to cut up a couple of things, but I can have the CNC do it, and I can be working on other things while that CNC is doing that work. So that's the nice thing about being able to multitask with this automation. So next slide. So coasters. Does automation make sense? So wood was only available in 0.8 inch, around there, thickness, but the coasters are 0.3 inches thick. So to have a CNC sit there and just mill away 0.5 inches is going to take a lot more time, especially when you're making 100 of them and you need them quick. And it's going to waste a lot of material. So it's a lot easier for me just to have them cut in half with a bandsaw, and so in that way you can double the amount of coasters per piece of wood that you cut, because you're cutting that piece of wood in half pretty much, or splitting it in half, and then you're also saving time and money, because you're all that time to whittle away 0.5 inches with the CNC. You don't have to do that anymore. You only have to do maybe 0.05 now. And so, but the design of those coasters are complex. So this is where CNC definitely comes into play, where, and I'll show a picture, and I think in the next slide, of what the coasters look like. But to get all those grooves and designs in there, it would be a bit of a task to do by any other means. So I can pass the time and cost savings on to the customer if I use a CNC, but slice everything with the bandsaw first. So next slide, please. So a Peacekeeper model. So it's going to be in a couple more slides. I'll show you the picture. But Peacekeeper model. I already had that design. The details are way too small and complex to be done by any other means other than the laser 3D printer that I have. And to kind of give you a context, I can print to the accuracy of a human hair on that laser 3D printer. So in that case, it's not impossible to make by hand, but it's impractical because, to take the time to actually try to get those in the design, I have it down to the bolts. Every single component of that rocket is on these models. So if I actually sit there and try to, add those things, then it's going to take a significant amount of time. Yes?
When you used to make those models on the lathe, how long would it take you?
I would say I didn't have the best of lathes, so it took me about 20, 30 minutes to kind of get it done on the lathe and get everything accurate. And when I do these 3D prints, the print may take 12 hours. For the Peacekeeper itself, it actually takes 12 hours, but it's 12 hours of me not interacting with the machine. So it's about 10 minutes of interaction where I'm actually telling where to print and all that information, getting it uploaded, and then pressing print, and then I walk away. And then I could go to sleep, wake up the next morning, or I can be here, which is actually going on right now. It's making rocket right now, and so I can be right here, and it's still working for me in the background. Yes. Oh, sorry.
If you're running something like you're doing right now, what happens with a malfunction?
So,
just quit? I mean,
so there's a variety of malfunctions that kind of go with it. So let's take that 3D printer that's running right now. If it malfunctions, it shuts off. And it also has it has a bunch of sensors in there that detects problems. So it'll either stop the print, or it'll actually correct itself. I've had times where it fixes itself. But that one is still a desktop printer, but it's on the industrial side of desktop printers. So, and so my other 3D printer that I made, that one is a very large printer, but it's an FDM printer, so like the hot glue gun example that I was giving. That one, it can, at worst, it will make a big giant ball of molten plastic and possibly destroy the whole printer. And in some cases, I never experienced that myself, but in some cases, it has caused a fire. So you have to be a little bit more careful with those and keeping an eye on those. I personally have not had that problem. What a lot of people do is they set up an online service where they can watch it with cameras and everything, and then also control it with cameras. So that way, if they do see a problem, they can automatically just shut off the printer from far away, so they can go to work or do whatever.
As long as they're not asleep.
Yeah, as long as they're not asleep for that one. So what's nice about my laser printer is I can actually, go to sleep, wake up the next day, and it'll be okay. Worst thing is I'll have a spill of resin, kind of thing. And that's the worst that has ever happened in, let's say, 2-3 years. And so, for the CNC machine, it kind of goes the same as the FDM 3D printer, where you got to keep an eye on it, kind of thing. Now I've worked with it long enough that I know what certain sounds sound like, and when it's about to mess up or something is going on, so I can be in like the other room, in like the living room or in the kitchen, and I can still hear it, and I know what's normal and what's not. And so I can just run over real quick and shut it off. But you do want to be in close proximity to your CNC machine while it's operating. Now, worst case scenario is you're just going to break your CNC machine, I think. Now, if you're working with like lasers and stuff like that, then you might run the risk of fire. If it, let's say, stays in one spot, let's say this machine malfunctions and this, like the coach center shuts down. then it'll just sit there in one spot and just shoot a laser. I mean, that's happened to me before. I've shot a hole through the thing, but the table I have is made of. It does not interact with that laser. So even though it shot a hole through it, it just went into the table, which is I think it's a steel top table, and the laser I have is not powerful enough to do anything. But let's say I had something that was a lot more flammable on that piece, then I could have started a fire or something. So you do want to keep an eye on a lot of these machines. So it's not a lot of times. It's not just press and go kind of thing. There are some levels of machinery that do achieve that, but as far as this is concerned, you can't leave it completely alone. You just stay in close proximity at least. I have an example of this rocket base. The base, I always call it the base. It's kind of the stand on which the rocket kind of goes into. And that has laser engraved text on there. And so, yes, you could do that by hand. You can, kind of engrave it by hand, but I would not be good at it. And the amount of time to actually engrave it is, I think, 10 minutes. So, with the CNC machine. So, at that point, it's a lot. You save a lot of time. You get the accuracy, and you get all the quality with the CNC machine versus doing it by hand. And there's an example of just using a hand tool or a hand-operated machine is the chamfered edges on there. It's a lot quicker for me to just take a router and then just run it along the router and do those chamfered edges than have the CNC do it, because the CNC will sit there and just go back and forth, and it'll give you nice nice chamfered edges, but it'll just take a long time to do that. And so it's a lot easier just to slide it through a router at that point. So that's one place where using a CNC to do those chamfered edges may not be the best. All right. Oh, pendant lights. Okay. So the pendant lights, they're made of acrylic. There's a lot of cuts and joints that I have to do. They were very, when I ended up with they showed me a couple things that they wanted out of it, and it was a very modern, very abstract designs for these lights. So they had a lot of pieces to them. I think each light had about 10 to 15 pieces, maybe about 10 pieces in there, and they all had to lock into each other. And so I could use a bandsaw, but the CNC would ensure that there would be less errors in the cuts. It would also be easy to upload those files that I already designed it with into the CNC and into the CAM software, then to the CNC. And so, and once the first few pieces are cut, it could still be cutting things, and I can also do all the other things I need to do to those pieces. So the customer wanted it to be black acrylic with copper faces. And so, so being multicolored, I have also vinyl cutters, and so I could either vinyl wrap the a copper piece of vinyl to the acrylic, or I could paint the acrylic. So that's another time where I needed to balance out the two. So the vinyl wrap is more expensive, but it saves me time and effort where I don't have to tape off anything. I don't have to let's say I did make a mistake, I don't have to, wipe off the paint or clean it up or do anything like that. All I have to do is apply the vinyl and go. And it instantly makes the copper. So, it would be quicker also to wrap. So it would be quicker to wrap, but also I could do that wrap by hand. But it's a lot quicker to use my machine to do it because it cuts it out in, I think, a few seconds. And it cut out a few minutes. It took a few minutes to cut out 22 pieces total that I needed.
Color is something you added to the other machine, or it's a separate?
It's a separate machine that I have. So the nice thing about my business is I have a bunch of machines that will accomplish multiple tasks, and so and it's all hooked up to one central computer, and so I send all that information out to the machines when I have a project going on, and it pretty much they do different parts of the project for me, and then I combine all of them all into one kind of thing. So a lot of times I end up meshing my CNC and wood or metal and 3D prints and a lot of materials. I end up meshing those into one to create an object. So what was nice about it is every time a piece would come out of the CNC machine, I could then take the piece that I cut from my vinyl machine and then just lay it on top. And then once 2 pieces came out, I could weld those together with acrylic weld. So that way it was just a process by that time. So first day started with the Peacekeeper model. I prepared the 3D print file and sent it to the printer. And then I planed, and while it was starting to print, I would plane the wood and begin the CNC process. So I prepared the files, pathway, code, everything that needed to be engraved. And then I started to laser engrave, and then I cut it out. It's a fairly quick process, takes about, I'd say 40 minutes total to engrave that wood piece and cut it out. So next slide.
So the laser cuts the plaque or whatever it is, just like a plaque or.
So, actually, I can show you right here. So this is the one that I was making. It's for Jim Burks, a good guy. I used to work with him. So this right here is a laser path. All the engravings right here are for with the laser. My laser is not powerful enough to cut through that thickness of a wood. So I actually have to switch over to a end mill bit and cut out the object. And so I engrave first, and I always mark with the laser a circle right there for 0. So just in case something messes up or I mess up, I know exactly where to put that bit to recenter it.
That's a 0 out.
To 0 it out. And so right here, this is for a coin to be put in. So this is the pathway. This is in the CAM software, by the way. This is the pathways that the bit's going to take to make a pocket for that coin, and this is the hole for the rocket to go into, and then this right here is that outside path that it's going to take to cut out the piece of wood.
How much was the laser attachment?
Laser attachment, I don't remember exactly. It's not that expensive. I use something called a JTech, or the company is called JTech, and use one of their lasers. They're easy to find online. So if you are interested in that, I want to say it was around $80, but or maybe $180. I can't remember off the top of my head, but it wasn't extreme. No, it wasn't. So
you can get them from Banggood for about $250, $300 something.
Yeah, you can get So you can actually find them quite a bit now. Just laser attachments and everything that will do that level of engraving. Sir?
The edge of the shield-shaped plaque was done with a CNC, or was it done?
The edges were done. It was CNC'd out, and then I ran it through a router. Okay. Yeah. So.
On your SLA printer, how long does it take to print that rocket?
That one is 12 hours exactly. So.
It's about the same speed as the film or the filament print.
I've seen some comparisons on that before. There's a lot of different factors that go into that, but both would take a while. Is kind of the answer for that. I think it takes a little bit longer, but the quality is there. So, in some cases, I think it'll do it quicker. It all depends on layers. So the more vertical layers that you have, the longer it's going to take. But it is a lot quicker at doing things that are spread out horizontally. So it also, that's a huge thing about it, is it's going to take a lot less time if it's spread out more horizontally than vertically. But for me to print these rockets.
How do you do that when your vertical distance is 2 inches? I'm confused.
So these are 2 different machines. So this is actually my 3D printer right here that does that. And the vertical on that one is, I want to say 9 inches. And then, I think. And then and this is the CAM software for the CNC. So I'm doing 2 things at once, really, right now. So, okay. Next slide, please. Once the model base was complete and on the CNC, I began making the coasters. So began the CNC process with that, compiling the code, the pathways, the files. I began with batch cutouts, and I would make 3 pieces per piece of. I would make 3 coasters per piece of wood, and I can show you a picture of that in a second. So while the CNC was working on the coasters, I routed and sanded the edge of the base, and then I applied finish to it. So you can see here, you can see that it's cutting out those 3 per piece of bandsaw wood there. And these are the results. And then I would pile those up off to the side. And then this was actually drying at the time, and which looks like the one I was passing around earlier. Just different text on this one because it's already come and gone. So yeah, next slide.
Question back here.
Sir, can you go back to the previous one?
Yes.
The writing there looks like it's like painted on black, but is that done because the tool actually burnishes the wood?
Yep. So the laser actually burns the wood. So that's why you get that black look to it.
And if the perimeter of that object had interior corners as opposed to exterior corners, what kind of edge treatment can you do?
So the thing is with interior corners, let's say that was, let's say this was inverted, or pretty much, you're going to have a round bit, and so that's going to cause a rounded edge instead of a sharp edge. And so usually the smaller the bit, the better as far as getting a more, at least a little bit more defined edge as far as when you're doing an internal cut. Yeah, that's the best I can say is, maybe try to use a smaller bit. I don't know, did I get the question right or?
What's the smallest bit you've been comfortable using?
On that one right there is, I've gone down to a 1/16 of an inch, but that takes a long time. You want to go really slow. You go slow with those because it's such a thin bit.
So was this text just the laser, or did you use a router bit and then darken it up with the laser?
Nope, just the laser. Just the laser did that. I think I have an example later on where it's like a time lapse of it engraving the logos on the back of the coaster, so it'll be a little bit easier to see at that point. But yeah, just the laser goes through. It does create a little bit of depth to it as well. It does cut away, and since it's burning, it leaves it nice and black.
Did you cut the challenge coin hole with your?
Yes, I did. So I cut the challenge coin hole with an end mill bit. So after I did the lasering, I always do the lasering first because it's easy to line up that way. So I always laser first and then I cut. So I did the lasering, put the end mill bit was already attached on there, and then I told it to go and do its pathway, and so it went down and cut out that hole, and then went around the whole thing, and that's about a 20-minute cut right there. Sir, I'm sorry, sir.
So you got it temporarily glued on some kind of backing so you can get the outside edge?
So what I like to do, since you can see my wasteboard's pretty beat up, but what I actually like to do in some cases like this is I actually bolt it down to the wasteboard. Also, what you could do is use those pre-drilled holes right there, and those threaded clamps. Yes, thank you. To hold down the piece as well. And so since this would be a rectangular piece, I would put the clamps here and then on each corner kind of area. And then that way it keeps it nice and sturdy while it's being cut. You want to actually watch it, especially watch it really closely during the last few cuts, because you may have measured wrong how thick the piece is, and you actually might be continuing to cut even though the piece is cut out and it's just like bobbling inside the frame of wood there. And so that last couple of passes on your machine, you really want to pay attention, don't take your eye off of it.
Could you use double-sided tape to hold that down?
I have seen some people use double-sided tape. I don't know if it's just I haven't gone to the trouble of going to the right shops or something like that. I haven't found good enough double-sided tape to accomplish that, but I have seen I've literally seen people use it. So double-sided tape works. It's just you have to have some good stuff to do to that.
I've been seeing a lot of people using blue painter's tape to put down on the wasteboard, and then they put it down on the bottom of their workpiece.
Okay.
And use super glue.
Super glue. Wow.
So they're gluing the tape to the tape, but that holds the piece down pretty well.
So I've been seeing a lot of people using that method more and more lately.
Really? That sounds pretty cool. I never thought that. So yeah, that would work out too. And then you got to be, I think in that case, you got to ensure that you're really careful of added thickness. If you're like doing something that's really dimensionally, challenging. Yeah. And so, but in the case of these plaques, that would be perfect, because I really don't care how thick or thin it is.
So on that picture, the slide up there on the top right corner, is that the end where you had extracted those each of those pieces, the laser cut it out?
This top up here? Yeah. So I actually used an end mill bit on that one, but I did cut those out, yes. And that's kind of that's the waste afterwards. That's the waste. Mm-hmm. That's the waste, and then that's the result. So the only difference between the two is about, since it's the 1/8 inch bit, is 1/8 of an inch border around it. So that's the difference. Sir?
Is there, since you're burning fuel, is there any point you have to be concerned about whether you're going to catch it on fire? Is there a point there that you have to worry about that, I guess?
Yeah, just kind of keep that in mind. I have never actually had an experience where it has caused an expansion of burning. I've even gone in the other room, and I had a little bit of electro interference, electronic noise going through it. And so I had touched something, I guess, and caused a static spark and shut off the machine, but the laser was still going. And so I came back, I was probably getting lunch or something like that, making lunch, and then come back eating my sandwich, and then come back 20 minutes later, expect a done piece, but it was still sitting there with the laser going, and it just burned a hole through it. That was about it, but it didn't actually cause a fire. But I would say, legally and safety-wise, be very concerned about that, but I personally have not witnessed it.
But it's working on a small enough area that's not creating a lot of heat on the part.
Exactly, yeah. So, all right, so next slide. Oh, did I get all the questions? Did you have a question?
How much control do you have over the depth of the printing?
So you're talking about CNC work? Or
when you're doing, because you said you did that laser.
Yes,
right?
okay, yeah, with the
laser.
So I have, that is easily controlled with how fast you have the laser go, and the speed is is kind of referred to as the feed rate, how fast you have the gantry moving across your thing, or your tool moving across, to include lasers. Your feed rate, and then also the intensity of how intense I have the laser turned up. And so I can make adjustments on those. So I actually have pretty good control over how deep it goes. And a lot of it also has to do with the material too. It's a little bit more temperamental as far as engraving lighter materials. And so lighter materials, and if it's white, then I have a really hard time actually engraving. I have to color it black, or draw some pencil over it or something like that to actually get it to react. So, but darker materials, it reacts very well with that laser diode. All right, so next slide. So a lot of coasters are being made. The 3D print of the Peacekeeper model was completed. There's a process with that. The 3D printing is, when you have an SLA print, is you have to wash off the print. You have to wash the excess resin off of it. And then you also have to cure it as well. Sometimes curing is required, but majority of the time you do have to cure those things. And then I began painting that rocket. While the paint layers were drying, I started designing the pendant lights. So you got to remember, the CNC is working on and carving those coasters. The rocket is almost done. The paint's drying on that one, and now I'm working on the design for the next project. So I'm working 3 projects simultaneously at this point. So this, the picture on the left is the Peacekeeper model. It's not the exact same one, but it looked exactly the same. And so that was it without paint. This is the middle pendant light that I ended up designing for the brewery. And then this is one of the outside lights. Both of them, the 2 on the outside were the same. So you can see how many pieces that have to fit into each other. And since it's already designed out here, then it's a lot easier to make with the CNC machine than if I were to try to attempt to do that by hand. Okay. So with the pendant lights design completed and painting on the Peacekeeper model done, I sent the design to the customer to review, and then I prepared the Peacekeeper model to ship. And then I continued CNCing coasters. I had a lot of them to make. But now the coasters are now in an assembly line process where once one is cut, it is sanded by hand. I like to sand it by hand. Sanded by hand and then moved to a pile. Once every batch of 5 or so gets into a pile, I would clear coat the back, or clear coat the front, I'm sorry, of the coaster. And then at the end of the day, I would take that pile of however many was in there, and then I would laser the logo onto the back of each of those coasters. And then I would put a clear coat right on before I went to bed. And then the CNC would still be cutting away. And then I would turn it off, of course, before I went to bed. And then, sorry?
Your clear coat, was that lacquer or what do you use for clear coat?
So I ended up, I have a favorite, and it's, what is it, the PFT lacquer. It's a spray lacquer. I love using that. Evidently it didn't work out too well for some customers. It worked great for others, but I think what had happened was there was a party and somebody had submerged these coasters in like wine had been spilled all over it, and so after staying there for a long time, it did eat away at the coating. So
It's not super water resistant.
yeah, and so that probably wouldn't have been best, but I didn't know that at the time. But it worked really well for most customers. It's just there was that one customer that had that going on. So you can see on the left hand side, that's a time lapse of it engraving the logo on the back, and then you can also see the finished result on the top right. I'll let that go real quick. That logo is that was a 3-minute engraving. So that's a period of 3 minutes, I think.
You use about a 2-watt laser?
I'm sorry?
Using about a 2-watt laser?
I think it's a 5-watt. 5-watt laser. And so that's it. Let's go back. And then also in the picture you can see the final product of what the Peacekeeper model looks like, and the final design of that one of the outside pendant lights in the brewery. And so the ones on the top right are drying. That's my little clear coat station right there. So next slide, please. So Peacekeeper is shipped now. Job is complete. CNC is still cutting coasters. And then I receive a go-ahead on the pendant light production. So then, while the CNC is still cutting, I can sit there in my programs and create the pathways and get everything prepared and ready to go for when I am done making those coasters. And then I can just throw the acrylic on there and then have it cut away. So I prepped all those files and did all the calculations to ensure that I had an optimal production process. Sir?
You must have slept during the time you explained the pathway.
The pathways. So pathways are it's kind of the path that the bit will take. So if you say this is like either a laser or an end mill bit or whatever tool you have, the pathway is the path that it's going to take when it cuts out something. And so that path is both in X and Y directions, and as well as in up and down the Z direction. So
you have to determine that?
So in the program, in your CAM program usually, there's predetermined pathways. So like there's something called a rastering pathway, which it'll go back and forth. So you kind of need to know what works best for your project. But that comes with just like practicing and messing around with it. But and you can also look it up fairly easily too, what works best. Once you select your type of pathway that you need to cut, let's say it's a profile. A profile is I cut out a piece. Then I have to go in there and define the values of how fast it goes, which is the feed rate. And then the depth, how deep it cuts per pass, like a pass is each time it goes around. And then I also had to define how quickly it plunges, this is the plunge speed, how quickly that bit plunges into the next depth. And then I have to calculate the rotations per minute that the router is moving at. So.
When you talk about the programming of this, my wife has a sewing machine that's pretty much amounts to a CNC embroidery machine. So, and there's so many patterns available. She wants something, she downloads it on a flash drive, plugs it in. Is there like a library or whatever, of pre-existing patterns that you can just...
So there are collections of pre-existing patterns available. And then a lot of these softwares do have it so where you can, clip art kind of thing where it's like, oh, I want a, star or something like that. And then you just draw a star.
Yeah, like your flag thing.
Mm-hmm. Yeah, or a diamond in that case, and then or a square. So there is a small library, but when it comes to pathways, you still have to define those pathways on how you want it cut, because you as the user know how thick your material is, you know how wide your material is, etc. So I think
any of those CAM softwares have an optimization process that can say, here's the best pathway given this design and material?
And most of them do. Actually, could you go back a couple slides to where it shows the pathways on there? Okay, so here, my CAM software, at first I went into the engraving tab, right? And so once I selected engraving, I said fill. And so all I did was I selected all that text and said fill, and it calculated all of it itself. And now it could do the same thing, and I could just say outline, and it'll go in there and it'll calculate how to outline it in the most optimal way. So pretty much as the user, you're just defining pretty much what type of pathway you're taking. The computer figures it out on its own, but you're really, in your definition, you're defining how fast it moves. Is in essence how fast and deep it's going to move.
Is it like picking a font?
You can pick a font through there.
For the curved surfaces, you have to determine how much faceting there is. Do you have control over that, or does the software determine it?
You have control over that. So you have control over those values as well. So any really speed and depth measurements or controls, you have control over that. So it's mostly just directional. That either you tell the program to come up with a certain direction, or it'll come up with it itself. So completed all that, pendant line production, calculated all the optimal pathways for the material to be cut. Okay, next slide. So now, finally, all the coasters have been cut out. Some still require sanding and clear coat, but now, at around that time, which was very opportune, was I received a phone call that the customer needed the pendant lights sooner, because they were like, oh, it's okay, next few weeks or so, that's whatever. But then they're like, we need it now, kind of thing, because I guess their lights started going out at the brewery, and and come to find out, the customers actually liked that because it was a little too bright in there. But anyway, I was able to place the acrylic on the CNC with everything already planned out. I was able to send take my vinyl and my vinyl cutter, cut all that out, and then cut out all the pieces or start the cuts on the CNC for the acrylic. So this is what the final product of the coasters look like. Those are the ash ones on the left, and on the top here, these are the walnut ones, and then these are mixed with the concrete ones that I sent over to that company with this. I made a silicone mold for them so they could do concrete ones too. So all the coasters got shipped off, job complete. Now I still have to do those lights. So CNC is still cutting acrylic, but I have an assembly line process now for that one. So take it out, kind of clean off the edges, clean off the acrylic, and take the vinyl, put it on top, and then I weld them together with acrylic weld. and then
It's like a super glue.
Yeah, it's more of like a solvent, and so it's an evaporative solvent. So pretty much what it goes in there, and it pretty much welds the two pieces together when you apply that solvent. But if you were to apply it to say wood and rubber or something like that, it's not going to do anything. It's just going to evaporate. So it only works with the specific material. And then 24 hours later, I finished all 3 lights. And they were installed in the brewery. So just about a day later after that.
Where did you get your copper vinyl?
I got it from Joann's, actually. Yeah, I didn't have time to actually. Well, I did have time to order it offline. The problem was online. They didn't have the right one that I wanted. I wanted it really shiny and everything like that. They had matte and everything. I just couldn't find the right ones online. So Joann's thankfully had some nice copper vinyl, and I bought rolls of it from there. And then I took it over to my machine, cut it out.
Is this vinyl cutter a knife or a laser?
Yep, it's a knife. It's so that particular one has a blade in it, and it just goes around and cuts it around.
So how big is that? How big is sheet?
So it's the machine's actually called Cricut. It's a Cricut machine, and that one I think it'll do about 1 foot wide by 24 long. So and then I think the rolls I bought were about 1 foot by 24 as well, so that worked out. And so these are the final products. And so the one in the middle there was just pure black acrylic, and then the ones on the side were those crazy ones with the copper and the black at the same time. So, and then they have hue light bulbs in them now, so they can change the colors and everything like that to go in there. So it looks pretty cool. So. Next slide. So in conclusion, automation can allow for a single person to do, or a few individuals to do the job of many people at the same time. Even if you're only doing one single job, automation can ensure accuracy or quality or a number of other things, or maybe even you save time. Versatility and quick iterations has been a plus in at least in my business, because sometimes I'll discover an issue. Let's say I'm making multiples of an object. I'll discover an issue, like they don't fit together like I thought they would, or the customer changes their idea and they want to add a hole here or do something different. I can make those changes in real time. And so I can, so instead of going to, like, let's say you had a regular traditional manufacturer and you're like, I want 100 of these, and they start making 100 of those, and then, well, you could be stuck with 100 things that didn't end up the way you wanted to. But if you're doing it with like a CNC or 3D printing or any of these other technologies, then it allows you to make changes to at least save maybe a good large portion of that batch. True, you can make a jig to make a lot of these objects, especially if you're going to make them over and over and over again. But if you ever need to make a change, then you'll have to change that jig, or you have to redo the jig or something like that. So, and then some machines can perform multiple tasks, like my CNC with the modifications on there. I can do engraving, I can do, I've cut leather on there before, I can cut wood, I can do metals, and so I can do a bunch of different things with it. And that's just one machine that I have in the corner. And so that allows me to work with a bunch of different types of things. So Desktop for Business has allowed me to create more, be more creative with my projects, and have increased quality. And actually, I don't know, you can ask her, but I think I sleep a little bit more now, or at least I still do run my own business, so I do still have a lot of late nights, but at least I'm not frantically pulling 24-hour nights trying to get things done. And by having multiple types of machines, I can perform multiple different tasks at the exact same time. And it reduces overhead by a ton, because I don't actually have to keep an inventory of anything. I just use what I need to make. So if I need to carve something out of wood, I'll go buy some wood, put it on there, but I don't need to keep anything in the meantime. I don't have to keep any finished products waiting to be sold.
Do you see yourself doing this 50 years from now?
I do. And so it's been a really fun opportunity to do. and I actually see myself doing this in the future, but to a whole new level and extent. So.
How did you even advertise or tell folks out there who might be interested in something like this that you even exist?
So that has actually been, I spent a lot of time last year working on that. I started going to different meetings and meeting with kind of my general customer kind of thing. So I would go to a lot of meetups where there were startup businesses because I do rapid prototyping. So then I would go to these meetups and be like, oh, okay, yeah, I can help you with your design. I can help you with your project or something like that. And honestly, I've been very thankful that I've had the jobs in the military that I had, because that at least started a word of mouth kind of campaign there where somebody told a friend, hey, this guy does this kind of stuff, and then they'll tell somebody else, and it'll kind of spread that way. And I've been very thankful to have that, at least word of mouth, go around. But
do you have a website?
I do. And I have a bunch of business cards up here. And so it has my website, my Facebook, Instagram, LinkedIn, everything on there. So I have all the social media things covered. And so beginning this year, I've actually started advertising on Facebook and started doing online advertisements. But before, I had not paid for a lick of advertising.
You're no longer in the military.
I got out at the end of 2016. So
Thank you for your service.
Thank you. I appreciate it. And it was at that point in time, it was like, either you stay and you retire or you go and do something else. And so I was like, well, I want to try starting my own business. So I kind of went for it. So
How many years were you in the Air Force?
I was in for 11 years at that point. And so.
So if somebody in here came up with a SketchUp drawing that wanted to print, you could do that for them, right?
Yep, I sure could. I could do 3D files. I could either 3D print them something, or I can CNC it, depending on what kind of outcome you want. Really. So,
when you engrave wood that ultimately you want to finish on the wood, do you engrave and then finish the wood, or reverse?
I engrave then finish on the wood. I've seen different ways of doing it. Because it's a burning laser, I've seen some people that like to finish first and then engrave on there. I've had really good results, at least with my settings, so I never needed to, and especially because I'm doing a lot of cutting afterwards, I always finish last. But that's my personal preference. I always got good results with that. Some people, I've never been able to successfully do this, but some people have put down masking tape, and they engrave on the masking tape so it doesn't burn everywhere else. I've never been successful with that, but I've seen other people do it.
Tell them about that one gift you did for Sergeant Goodnight, where you had to engrave and finish, and the issues that you had with that. I can pull up the picture.
Do I still have that? She loves that one. So that one, it was I did a silhouette of an SR-71 as a shadow box, and so he was retiring. And he had his flag, and the SR-71 inspired him and his brother both to get into the Air Force, and so that meant a lot to them. And so what I did was I took the silhouette of the SR-71, and then I engraved each patch of for each unit he had been in over his entirety of his career, and I put it along the fuselage and the wings and everything like that. So that one was a challenge though, because I carved it out of plywood, and then the SR-71's black, but then I also had to fill in the engravings with another paint color. So that was a bit of a challenge where I had to actually I painted the whole thing silver, and then I carefully brushed over the top of each engravings with black paint and everything, and tried not to get any of the paint into the engraving. So that was a that was a bit of a challenge for me. Wow. If you're gonna do bare wood and you have an engraving that you want to fill in with another paint color, you can just run that through a planer and it'll just kind of come off, or you can just sand off the top or something like that. But if you're trying to do multiple colors, then that can start to cause a bit of a challenge. So yeah, that was a fun one. But he loved it and he was happy. So.
Picture on your website or on your Facebook?
Yeah, you're not connected to internet though. Oh, you are? Yeah. It's on Facebook and maybe Instagram, but definitely on Facebook.
On this piece of aluminum that you're passing around, did you use a laser or a bit?
On the aluminum?
The perimeters, right.
That one, I have special bits for metals. I have an engraving bit that will do those aluminums and brass and copper, etc. And then also have other in-mill bits that will cut out.
Cut out outlines.
Mm-hmm. Yep. So.
If you could cut copper, was there a reason why you did acrylic with the vinyl overlay as opposed to just cutting it out of copper sheet?
Expense. Expense, and then the ability to attach it to the acrylic. With the vinyl, all you have to do is, with a squeegee and a heat gun, you can just get the vinyl on there and it'll stay for a long period of time. If I did the copper, you could very well do that, but you would also have to make sure that it gets attached in a way that doesn't come apart. So even glues may not hold up to the smoothness of the copper and the smoothness of the acrylic, and put both those together. And then also weight too, because it's just dangling from a typical cord that you have for pendant lights, and so the weight will also cut into that too. And so I'm pretty much done with my presentation. So any more questions or anything?